Intro Algebra Lesson 3-2B. Keeping in the frame of solving the equations using the inverse of multiplication and division, we talked about some common mistakes that people make, and we'll try to point out a few more. Here's some more examples of what we want to try. We want to solve and we want to get A alone. We've got to remember that this line right here represents the division. So A is being divided by 2 right now. The opposite of dividing is to multiply. So we'll multiply by 2 over 1. I want the 2's to be on top and bottom so they'll cancel out. What you do to one side, you must do to the other. They cancel. A now equals negative 14. Again, you can check this mentally by plugging that negative 14 back into the original situation. And negative 14 divided by 2 is in fact negative 7, so we know we have the right answer. Inverse of division is multiplication. Alright, little trick here because over here you have a mixed number. I might recommend to you that you change that mixed number into an improper fraction. So we're really dealing with y, 1/3 times y is equal to 5 times 3 is 15 plus 2 is 17 thirds. Now you want to get rid of this 1/3. Remember, if you want to get rid of a fraction, multiply by its reciprocal. So if we multiply by 3 over 1 here, we have to multiply by 3 over 1 here. The 3's cancel, the 1's cancel, leaving y completely alone, which is what we want. And over here, the 3's cancel, leaving you with 17 over 1, which is 17. So you could test that out, and you could put 1/3 times 17 over 1. If you wanted to test it. 1/3 times 17 over 1, that's going to be 17 over 3. 3 goes into 17 5 times with 2 left over. 5 2/3. It works when you plug it back in. Alright, same concept. I want to get rid of r. I want to get r alone, so I want to get rid of negative 3 over r. So I multiply both sides by the reciprocal, 5 over negative 3. What you do to one side, you must do to the other. If you want to get rid of a fraction, multiply by its reciprocal. They cancel, 5. Don't add these together. Over negative 6 is equal to r. Inverse operation. You must do whatever it takes to do the opposite of what's there to get the variable to be alone. Similar triangles. This is the symbol right here for similar. And then that's, go figure, the symbol for triangle. Equal, corresponding, or matching angles. Now that's a little tricky. Equal means the same. Corresponding is another way of saying matching. So this angle right here corresponds to that angle right there, because it's in the same location of the triangle. Right? If I put 2 arcs, it means it's a different value than this one. So it would match up there. And up here, 1, 2, 3 is going to match with 1, 2, 3. Probably be better if I made these a little bigger. I'll get rid of that. So, that's the same as that. That's the same as this. And these 3 arcs there match up with those 3. So those are matching. They would have the same value. They would be equal. Based on that, is there a way to figure out if these are actually similar triangles? Is there a way to figure out this value right here? All right? We can make what's called a proportion. So I've got a couple of them here to think about. If you look at this proportion, I would say that you match it up so that the bigs and the bigs are either across from each other or on top of each other. It doesn't matter. I don't want bigs to ever be diagonal. I don't want smalls to ever be diagonal. You can either go big to big or big to big. Small to small or small to small. But you can't ever make them diagonal. I don't ever want the bigs to be diagonal from each other, and I don't ever want the smalls to be diagonal from each other. So looking at your parts, what's a part of the big triangle that you know? Well, there's a part of the big triangle I know, which is 8. What's another part of the big triangle? 4. Right? On the small triangle, I know a couple pieces. But which one is in the same location as on the big triangle? Well, over here I had said 8. 8 was this kind of slanted line here. That's in the same location as this one, so I would say 6. And then the 4 is across the bottom of the big triangle. It appears to be in the same location as across the bottom, which is x. Now there's a couple ways you could do this. There's actually a number of ways. This is a proportion where one fraction is equal to another. You could say to yourself, well, 8 got divided by 2 to equal 4. So to keep it fair, I could divide by 2 and I'd get 3. X must equal 3. And that's completely legitimate. You could do it that way. But what's cool about proportions is that their cross products are equal to each other. In other words, if you take 8 and multiply it by whatever x is, it has to equal 6 times 4. So 8x has to equal 6 times 4, which means 8x equals 24. And if you recognize, that's what we've been working on. The opposite of multiplying by 8 is to divide by 8. And we end up with x equals 3. The exact same answer that we had before, so we would say 3 centimeters. Again, I realize that you might be able to just go, well, half of 8 is 4, so half of 6 is 3. That works, but you might not always have a number up here that makes it quite so easy to see. So if you have a way of setting up a proportion, remember, never set them up diagonally. You do not want to put big triangle here, small triangle here, small triangle there, big triangle here. This would be no good because they're diagonal to each other. Don't set it up like this. Be very careful about that. Other than that, it doesn't matter. You can go big triangle here, the other part of the big triangle here. Small triangle over the same small triangle. That's okay because it's vertical. It can either be horizontal or vertical, just never diagonal.